Hello there, and then welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. Now, in this lesson, we'll define and then explain the two key components of the slope-intercept form, and then we'll demonstrate how to graph a line using these two values. So, without much ado, let's quickly look into it. So, when we talk of the slope-intercept form of the equation of a line, let's say it's a standard way to write a linear equation in two variables. And in that two variables, we are talking of y equals mx plus c. I do hope you've seen this before. Now, this x and y over here. So the x that you have as this, and then the y as this, represent any point at all on the line. So they are coordinates of any point that lies on the line of this equation. The c, on the other hand, is what we call the y-intercept. The c is the y-intercept. So talking of the y-intercept, if I'm to have a line, I'm coming to draw a line over here. So this is my line. Okay. So where does this line touch the y-axis? Remember, this vertical one is our y-axis, whilst the horizontal one is the x-axis. So where does it touch the y-axis? It touches it here. That is what we call the intersection. You see, so if that is it, then we would call this also the x-axis, and the x-intercept. You see, so if I bring my line here, this point now becomes my y-intercept, whereas this becomes my what? X-intercept. Now, since it is a point, then it also means it is written as a coordinate. You see, so the y-intercept is then written as, now we should take note that since it is a point on the y-axis, x is 0. So if you want to write the y-intercept as a point, then it is going to be 0, 0c. This here is the y-intercept. I do hope that is clear, because the x coordinate is 0, whilst the point on which the line touches the y-axis becomes our c. I hope that is clear. With that said, we then look at the m. So the m, on the other hand, represents the gradient or the slope. Now it represents the rate of change or the steepness of the line. Now, with that being said, if you have two coordinates or 2 points, so you have x1 and then y1, and you also have another point x2, y2, then the gradient of the line joining these 2 points, m, is giving us the change in your y value over the change in the x value. Change in y value is simply written as your y2 minus y1 all over x2 minus x1. It is also the same as y1 minus y2 all over x1 minus x2. The most important thing is you stick to the order to which you are using to operate. Okay. The gradient has so many values. Specifically, we'll look at the positive in general, negative in general, 0, and then an undefined slope. So coming back to our graph here, I'll make some demonstrations here. First of all, if our gradient is greater than 0, okay, so if the gradient is greater than 0, we say you are having a positive slope. That is, the line you are talking about has a positive slope. And one characteristic of a line that has a positive slope is that it rises from left to right. So a line like this has a positive slope. You see, because it is rising from the left hand side all the way to the right hand side. It can be anyhow, but the most important thing is it is rising from the left to the right. And then we would say the line has a positive slope. The next one you should look at is when your gradient is less than 0. So when gradient is less than 0, then we say it has a negative slope. And for negative slope, it is falling. You see, so it falls from the left to the right hand side. That is a negative slope. It falls from the left to the right hand side. That is a negative slope. Then if the slope is 0, a 0 slope is that which is horizontal. So that is if m is equal to 0, then we are simply talking of a horizontal line. A line that is parallel to the x-axis is always having a steepness, a gradient, or a slope of 0. Any line at all, so far as it is parallel to our y-axis, then the gradient is 0. Then the last type we'll be looking at is when your gradient is undefined, or we say when your gradient is infinity. So for gradient being undefined or infinity, it is straight and parallel to the y-axis. You see how the y-axis look like? Very straight like this. Any line that is parallel to it is having a gradient of infinity, or we say it is undefined. With all these said, let's answer some few questions just to test our knowledge. So looking at this first question here, it says you identify the slope and y-intercept of the line y equals 2 over 3x minus 1. You see, so how do we go about this type of question? First of all, we know that the slope-intercept form is written as y equals mx plus c. Now the equation we've been given is y equals 2 over 3x minus 1. So all you need to do is to compare the values. So as you can see, our y is our y over here. X is still x over here. The coefficient of x is m. So comparing that, then we can say that from observation, our m is equal to what? 2 over 3. The same applies to what you have here. Your c is equal to what? Negative 1. You see? So this simply implies that your gradient or the slope is 2 over 3, and your y-intercept. Now we write the y-intercept as a coordinate. So at the y-intercept, x is 0. So our y-intercept is 0, negative 1. And that is it. Your question is solved. Very, very simple and direct. So in simple terms, if you are asked to find the slope and then intercept when given an equation, all you need to do is to make sure you write the equation in this form. Okay, then you just compare the values. Let's take one more example. For this next question we have here, it says identify the slope and y-intercept of the line 2x plus 4y equals 8. How do we go about it? So remember, as I've said, the slope-intercept form is written as y equals mx plus c. Taking note of this, you realize that the coefficient of y is 1. You see, so if you are given this equation, we simply have to write it in this form over here. In other words, all we want to do is to make y the subject. You see, so making y the subject, we have our 4y equals 8 over here. So we want to move this 2x to the other side. And doing that, because it is a positive 2x over here, it moves to become a negative 2x. And take note, we want to write it in this form. So then let's write that of the x first, so that we have 4y is equal to negative 2x plus 8. We have not changed anything. It is just a rearrangement. With this done, the coefficient of y is supposed to be 1, but over here we have it as 4. So I'm going to divide each and every term by what? 4. So we divide by 4, we divide by 4, and also divide by 4. By so doing, we have 4 over 4, which gives us y. Then negative 2 over 4 gives us a negative 1 over 2. Not forgetting our x. Then x, 8 over 4, on the other hand, also gives us what? A 2. So with this, comparing it with y equals mx plus c. That is comparing our y equals negative 1 over 2x plus 2. You can observe what your m is. So it simply implies our m is what? Negative 1 over 2, which is the slope. And the y-intercept as c is equal to 2. And then the coordinate of the y-intercept is then going to be what? 0, 2. This is the coordinate of the y-intercept. So basically, this is how we solve questions with respect to the slope and then the gradient. As usual, I'll leave you with some exercises for you to try on your own to test your understanding. So these are the questions you have here to test your understanding. The first, you have to state the slope and y-intercept. The second, which point represents the y, then the y-intercept, and then the third one, you are just to rearrange. That ends this lesson. In our subsequent lesson, we'll look at how to determine the slope-intercept equation when you are given 2 points. Stay blessed, and then see you in our next lesson. Bye for now.